right, guys, for today, last week we learned all the new ways of factoring. Today and tomorrow and Wednesday, we're working on solving. I'm going to teach all of it today, but then we're going to kind of do some activities the next 2 days to work on sorting them and knowing how to solve them and which method is which and all of that good stuff. Remember, you have IXLs. Hopefully you've been continuing to work on those to get your practice. Today is solving. I may not do all the examples in your notes just for sake of time, because I want to get through the different types of all of them and try to give you time to work in today. Okay? All right, so we are solving today. So I threw on here your factoring flowchart just because I think it's helpful to kind of look at what are your options for how many terms you have. So obviously we have 2 terms. Difference of squares is what we had done always, my favorite. And then you also could have sum or difference of cubes. And I did break it down on your flowchart, if you have not looked at that in a while, all of how to do that. 3 terms, I have on here the x squareds, but what also falls in this category? X to the 4th, your cortex. They factor the same way. And then 4 terms, that's your grouping. Right? That's all your different types of factoring. All right, so when you are solving by factoring, put the equation in standard form, get it equal to 0. Okay, factor completely based on whether it is quadratic. What's quadratic mean? Good, that means it's x squared. Whether it's quartic, factor by grouping. What's that? What's factor by grouping? When do I do that? Not x to the 4th. How do you know if you're using grouping? 4 terms. Or sum and difference of cubes pattern. That would be an x cubed, and you'd have 2 terms. Just trying to keep track of all the different types of factoring we have. Because when it comes time for your quiz, which will be on Thursday over all of this. Yep. Your quiz on Thursday, yes, the end of the quarter is Friday, so it will be on this quarter. They're just going to be all mixed together, and you're going to have to look at it and know which type it is, factor it, and solve it. Okay? But again, we're spending today, Tuesday, and Wednesday practicing all this before the quiz on Thursday. All right, you will set each factor equal to blank and solve. Set them equal to 0 and solve. Remember, the blank of the polynomial is equal to the number of solutions, or zeros. How do you know how many answers you're going to have? Now, how many terms? The exponent. What do we call the exponent? Degree. Right, so if it's a quartic, how many answers will you have? 4. That's a big thing. Like, if you're going through your solving, you're like, yep, I got my 2 answers. And you're like, whoa, it's the next to the 4th. Why do I only have 2 answers? That should be a red flag for you. Right here is something that hopefully you pick up on from chapter 4, but if not, make sure you make a note of it. If you cannot factor completely to linear factors, meaning x to the 1st, like an x plus 2 and an x minus 5 or whatever, then you may have to use the quadratic formula or the square root method when necessary. Okay? And hopefully at this point it becomes second nature to you when you're solving. Like, oh, I can't factor, I'll just choose another method and go for it. Solutions or zeros may be blank or blank. I agree, but not what I was looking for. Really? Nobody at this point? There it is. They can be real or imaginary, so watch for those eyes. When does an I show up? Very nice. And there's a negative underneath your square root. Perfect. All right, we're going to jump right in. First type hopefully should be review for you guys, so we might not do all of these on here. But number 1, first step, I'm supposed to solve by factoring. What do I do first? Set it equal to 0, make sure it's in the right order. So I have 2x to the 4th. I'm going to leave that one and move the 2 pieces, that way that stays positive. Bring the 5x cubed over. Bring the 12x squared over. And we'll set it equal to 0. What do you look for first when you're factoring? GCF, which is? Good. All right, so take out your x squared. We have 2x squared minus 5x minus 12 equals 0. What type of factoring do I have left now? It is quadratic. Quadratic is what we've done all the time, right? This is your guess and check method. But before I can determine if it's quadratic, quartic, cubic, any of that stuff, you have to take GCFs out first. All right, so since it's quadratic, I'm going to set it up for my guess and check method. What are my signs? Plus, minus. Okay, options for A. 1 and 2, so 1x and 2x. All right, options for C. 1 and 12. All right. 3 and 4. Where can the 4 not go? Can I put a 4 in with a 2? No, there'd be a GCF then. So if you're going 4 and 3, I would have to go that way, right? Because you don't want to put a GCF inside of here. So that's going to give me 8 minus 3. Flip your signs. Good. Again, if you need to write down that checking, write it down. I'm just hopeful at this point I don't have to write every single little step down for you guys. All right, so there it is factored. You guys know how to solve now, right? So what does x equal? Here, what's baby brother give me? 2 zeros. 0, 0. X minus 4 gives me 4. Negative 3 over 2. There you go. And how many answers do I have? I have 4. The original problem was x to the 4th. I have all of my answers. Just do that little mental check, though. How many answers do I have? How many should I have from the original problem? Make sure it matches. Questions? We good? Let's skip to overachievers. Sorry. Say that again. We'll start long division on Friday. So you have from now until Friday to remember how to do long division with plain old numbers, okay? Of course. But we're doing long division with polynomials, so you can't just type the whole thing in your calculator. I hear people say that all the time, and I call malarkey. All right, number 4. Let's skip to number 4. I'll reteach regular long division before I teach you craziness with polynomials, I promise. You'll be fine. So number 4, what do you do first? Good. Set equal to 0. So I have 9x to the 4th minus 64x squared equals 0. Good. GCF would be what's the GCF? Just an x squared. Thank you. I know what you're thinking of, but we have to take out our GCF first. All right, so then we're left with 9x squared minus 64. Take out your GCF, then tell me what type of factoring do I have. I have difference of squares. Good. And that's where Adrian was saying 3 and 8, right? So that's going to give you 3x plus 8 and 3x minus 8. All right, and then to solve, baby brother gives me what? 2 zeros. And then my other answers? Good. Negative 8 over 3, positive 8 over 3. If I want to be a lazy mathematician, how else could I write that? Yeah. If it was me, I would have written 0, 0, plus or minus 8 over 3. That's what I would have written. Okay. And if you recognize that, by all means, you can write that. Also, I want you to start to recognize if you see a plus minus, how many answers does that give you? That's 2. Okay. Questions with quadratic, I feel like we've done enough of those. I don't want to, what's the phrase, beat a dead horse? It's a terrible saying. All right, so let's move into the quartic ones and see kind of how our answers change a little bit. So number 6, what should we do first? Good. Set it equal to 0. So x to the 4th plus 2x squared minus 15 equals 0. Is there a GCF? No, nothing goes into all of them. Okay, so it's quartic, right? Because it's x to the 4th. How do I treat quartics? Like quadratics. I still do them like guess and checks. So, okay, so if I set up my parentheses, what are my signs? Instead of x and x, you're going to have x squared and x squared. Options for C, 5 and 3, positive 5, minus 3. Either of those difference of squares that factor further? No? Okay. Now, I know we do a lot of solving in our heads at this point, which is fantastic. But let me take this one back, not necessarily all in your head. Because we would set these equal to 0. And then we solve, right? That's what we're doing when we're solving them in our head. But notice what happens here. When I go to solve this, I get x squared equals negative 5. How do I solve that for x? I have to do the square root. So then x equals what? I agree with part of that. Thank you. So there's 2 of my answers, plus or minus I radical 5. Solve this one. X squared equals 3. Take the square root. Good. Plus or minus radical 3. So there's 2 answers there and another 2 on this one. So there's my 4 answers because it was a 4th degree. Okay, so not terribly difficult, just you got to make sure you're not going so fast that you're like, oh yeah, it's negative 5 and 3. No, because you got x squared is that. So you have to take the square root of them. All right, let's take a look at number 8. Guys, you want to try this one on your own? Okay, number 8 on your own. All right, let's take a look. Some of us forgot some of the little details of things. Bless you. All right, so first set it equal to 0. So subtract the 2. Some of us got a little rusty on not remembering or figuring out how to factor this. We struggled a bit there. Some of you I tried to walk by and I was like 1 and 6, 1 and 6, right? We got a plus and a minus. So we're going to want to go 1x squared and 6x squared. Option here is going to be 1 and 2. I'm going to go 2 and 1. So that's 12 minus 1. So there it is factored. Okay. Then when we set these equal to 0 to solve, x squared plus 2 equals 0. 6x squared minus 1 equals 0. Most of us did okay here, right? X squared equals negative 2. Take the square root. So plus or minus I radical 2. So there's 2 of your answers. Here's where we struggled a little bit. 6x squared equals 1. Divide by 6. So x squared equals 1/6. And some of you did your radical. You just drew a big old giant radical over the whole fraction and left it. How do we take the square root of fractions? Top and bottom. That's how we do those. What's the square root of 1? 1. Radical 6, I can't do anything with. And then you can't leave a radical on the bottom. So x equals plus or minus radical 6 over 6. There's your other answers. Okay? Just don't forget, we have to rationalize square root of fractions. We do top, we do bottom separately. Okay? Good. Are we seeing how last chapter is feeding into this chapter? It's going to happen all semester long. It always happens. All right. Let's do number 10. Number 10. Let's do this one together. What do you want to do first? Subtract the 13. All right, so we get 81x to the 4th. What is negative 108 minus 13? Minus 121. Is there a GCF? There's not, but you always want to look for that, right? There's no GCF here. It is a negative. So this is our difference of squares. I know it's quartic, but they behave like quadratics do. All right, so how does it factor? 9 and 11. That's how it factors?
9x squared plus 12.
Thank you. I mean, if I would write down exactly what students tell me sometimes, that's kind of comical. All right, so there it is factored, difference of squares. Set each one equal to 0. So 9x squared plus 11 equals 0. 9x squared minus 11 equals 0. All right, so subtract 11. Divide by 9. So x squared equals negative 11 ninths. Square root, top and bottom. Don't just draw a giant radical. So then x equals, what do we get? Plus or minus? Do I need to rationalize anything? Nope. So there's two of my answers. Two of them are imaginary. Would I see the imaginary answers on a graph? They don't cross. So do I really see them? No. I know they're imaginary because they don't cross, right? But yeah, I don't actually see them. All right, over here, are these going to be imaginary also? No, they're not. Because when I move the 11 this time, it becomes positive 11 divided by 9. So x squared equals 11 over 9. Square root, top, bottom. So plus or minus radical 11 over 3. Will I find that one on a graph? Yes. It will be an ugly fraction or ugly decimal on my graph, but yes, it will cross the x-axis. Mm-hmm. Yes, you can do that. Because if you watch mine, I don't show any of that on either of them. I do it all in my head. But yeah, no, if you're cool with that, if you recognize the difference, yep, totally fine. Not necessarily. I mean, granted, if you get it wrong, yeah. Yeah. All right, questions on the cortex? Again, does anybody want to see any more, or are we okay? We're good? Moving on? Good. All right, factor by grouping. Let's take a look at what those look like when we solve. So number 12, good, set it equal to 0 first. All right, so number 12, we set it equal to 0. Good. Right away, 4 terms. Your brain should see 4 terms, you automatically think grouping. So group the first 2, group the last 2. Don't forget to lose that, don't lose that minus sign in between there. GCF in the first set. What's left when I take out an x squared? Good, don't lose that 1. Some of you still have a tendency to drop that 1. Because you're like, there's nothing there. There's still a 1. GCF here, negative 3. So we have x plus 1. Is that factored? Am I done? Because I factored out a negative 3? Negative 3 divided by negative 3 is a positive 1. Good. We have to finish this. I have students every year who stop here. You're not done. Common factor goes here, which is x plus 1, right? This is your common factor. And then you have leftovers. I don't care the order. And it would be x squared minus 3. That is factored. Don't stop a step early. Okay, so now it's factored. Now let's set them equal to 0 and solve. What's this one going to give me? Negative 1. And then here, we'll have x squared minus 3 equals 0. Add the 3. Take the square root. So x equals. Good, there's 2 answers. There's my third one, and it started x cubed. So I have all my answers. Now, the question always comes up, how do I know whether or not I have to take the square root in my answer? Students ask me, like, why did you take the square root there, but you didn't on the other one? One has an x squared in it. Seems kind of obvious, I think, to most of you, but some of you are like, oh, I got it now, right? Okay, so if you have an x squared in your factor, you're going to have the square root going on down here. Okay? All right, how about 13? Set it equal to 0. Yeah. Question? This is 2 answers. a positive radical 3 and a negative radical 3. All right, yeah, 13, let's set it equal to 0 first. So 4x cubed plus 4x squared minus x minus 1. All right, we see we got 4 terms, so that's grouping. First 2, last 2. GCF in the first set? Just x squared? 4x squared. We're left with x plus 1. GCF in the second set? What's GCF here? Thank you. Left with x plus 1. Am I done? Factored? No, that's not factored. Can you tell why I keep saying this to you? Because it happens all the time and it drives me crazy. This is not factored. Common factor is x plus 1. Leftovers, 4x squared minus 1. Yeah, it's totally fine. And then we set each one equal to 0. What's x equal here? Negative 1. Here, 4x squared minus 1 equals 0. So 4x squared equals 1. Divide by 4. X squared equals 1/4. Square root, top, bottom. What's the square root of 1? Square root of 4. And don't forget plus or minus. Now, did anyone do anything else or think to do something else besides just solving it from 4x squared minus 1? Luke? You rationalize. Luke made it harder. Does anybody recognize what 4x squared minus 1 is? It's the difference of squares. You could have factored that one further. This would have factored 2x plus 1 and 2x minus 1. That's a difference of squares. Hey, look, there's your plus or minus 1/2 coming from those. So, do you have to keep factoring? No, not necessarily. I'm okay if you don't, because when you solve, you get the same answer. So whatever you're comfortable with. Now, if the directions were to just factor, and you stopped at 4x squared minus 1, I'd take points off, because you didn't factor all the way. But if you're solving, I can still get the right answers without factoring further. How do we feel on grouping? Okay? You want to try one on your own? No? I think we should. Let's do number 14 on your own. Now let's talk through this, see how we did. So set it equal to 0 first. Some of you struggled on the basics. When you set it equal to 0, make sure it's in the right order. So the x squared should go next, then the 24x, and then the positive 16. Okay? So then we group the first two, group the last two. GCF in the first set, x squared. So we'll have 3x plus 2. GCF in the second set. So then we're left with 3x plus 2. Common factor is 3x plus 2. Leftovers. It doesn't matter. That's just how my brain has always been trained to do it, but it doesn't matter. It really doesn't matter. All right, so there it is factored. Questions to that point? All right, solving. This one we can probably still do in our head, right? It'd give me negative 2/3. This one, set equal to 0. So we get x squared equals negative 8. Square root. So x equals plus or minus 2i radical 2. I saw a couple of you pulled out I radical 8, which is great, but 8 does simplify to 2 radical 2. Not sure what you had going on. You had some extra stuff in yours. Or were you doing a different problem? Oh, you were doing the next one. All right. Questions? Are we good? No. All right. let's move into sum and difference of cubes. Sure. Dakota? Sure. All right, guys. Last part, sum and difference of cubes. So let's just start with number 16. Very simple, basic one. So 16. It's already set equal to 0. Is there a GCF? Nope. We recognize it's cubes, though, right? Because it's 2 terms and there's an x cubed. Remember the pattern. Good. Small parenthesis, big parenthesis. I like that. You must always use soap. Good. Same sign as the original problem. Opposite, always positive. And then how do we get the numbers in the first part? Cubed root. What's the cubed root of x cubed? Cubed root of 27. Do I care about the original problem any longer? How do you get the numbers in the second part? Good. Square, multiply, square. What is x squared? Multiply x times 3. And then square. What's 3 squared? Will that ever factor further? No, it will not factor further. Now we have to solve. You were the one that brought that up last week, weren't you? How to solve that? What does this one give you? -3. Wasn't that you, John, that talked about that one? How do you, if it doesn't factor, quadratic formula. Bless you. Bless you. All right, guys, I want to make sure we're clear. This will not factor further. So when, bless you, Jonas. Bless you, child. All right, it doesn't factor further. So how do you solve something that doesn't factor further? Quadratic formula is where I would go. All right, so then we have x equals -b, which is 3, plus or minus. Guys, relax, guys. All right, b squared minus 4 times a times c all over 2 times a. Do I need to play the song again, or are we okay? In your head, you were singing it, weren't you? You can't help it. So 3 plus or minus the square root of, what do we get inside of there? -27? I have a tendency to agree with the -27. It's frightening. All right, so we get 3 plus or minus. Let's clean this up. What happens when we clean that up? We get an I. Thank you. 3i, radical 3, all over 2. Can you divide all 3 numbers? No. 3, a 3, and a 2? Nope. We are done.
So how come we did that?
We needed to solve this, but it will not factor further. You could have completed the square if you wanted, but yeah, this one's usually what people go with. This one, will this show up on a graph? It's imaginary, it won't show up. It would be, wouldn't it? All right, let's take a look at 17. It just happens to cross at a weird, yeah. All right, 17, guys. It's already set equal to 0. Is there a GCF in that one?
Numbers like this, and then they shrink down to like nothing after that.
They do. What's the GCF there? It is 2. Hey, guys. I need you to come back to me, okay? 729, thank you. No, I didn't. Just checking to see if you guys are paying attention. You passed. That's what you guys always tell me. Thank you. All right, so GCF. You're like a weapon. Well, I used to have one. Somebody took it. I used to have one on my desk. All right, so we took out our GCF. Now are they cubes? Yes, so make sure you take out the GCF. So let's go ahead and factor our cubes. One little parenthesis, one big one. Soap, right? Same, opposite, always positive. Take the cubed root. What is the cubed root of 64x cubed? 4x. Do not write 8x, because that would be the square root of 64. Cubed roots. And the cubed root of 729 is 9. I don't care about the original problem. Square, multiply, square. What is 4x squared? Multiply 4x times 9. 36x. Again, I don't care about signs because I filled them in first. And then 9 squared. 81. Oh, that's a lovely big numbers in there. Will that factor? Bless you. You threw it at her. Now she's sneezing. It will not factor further. Don't try. It will not. I promise you. Okay? Baby brother, does he give me an answer? No, I don't care about 10. There's no x. What does this give me? What is this? 9 over 4. No! All right, time out. Time out. X equals 9 over 4. Say that again? There's no square. Don't take the square root just because you want to. Right? You can't. People are like, oh, 9 over 4. Yeah, it's 3 over 2. It simplifies. No, it doesn't. It does not. Right. If this was an x squared, then yes, it would be plus or minus 3 over 2. But there's no square. How do you solve the other part? Quadratic formula. All right, so x equals, oh, these numbers are lovely. Negative b, negative 36, plus or minus square root 36 squared minus 4 times 16 times 81. You don't need to tell me that. I can't fix that. Over 2 times a. No, still don't care. Write smaller. Isn't that pretty? That's pretty. So negative 36 plus or minus the square root of... Anybody want to tell me what that number is? 3,000 what? 3888? Oh, that's going to be a pretty factor tree.
Better not be a factor.
Well, yeah. Would you be impressed if I told you I knew what it was without even doing it?
Yes.
No, because
I didn't memorize this. This is the first time today I've taught this class. Or I recognize the pattern.
please remember.
No, I didn't remember. This is the first time I taught it today.
No, you sat at home on Sunday and like, I'm going to trick you.
Hey guys. Some of you just continue to do your factor trees and simplifying, okay? Those of you who are smart enough to figure this out. Look at the answer from number 1, the first one. I'm not calling you stupid. Some people just get confused. And then look at my answer from the second part. Granted, I'm not done. I haven't simplified it yet. 3i, radical 3. I have a negative 36, a 36i, radical 3. These first numbers, this number and this number are the same. This number and this number are the same. They both have an I. And it's always a radical 3. So for me, when I'm like writing all this out with you guys, it's painful because I know where it's going in the end. It's faster for me to just jump right to this. Now, we'll do the next couple and I'll show you without actually writing it all out how it all works. But let's simplify this. Hold on. Just hang with me. All 3 of these divide by 4. So we get negative 9 plus or minus 9i radical 3 over 8. The cubed ones just get better and better, right? They're this weird numbers that when you work them through, you get this crazy pattern that you don't guess and check, right? You take the cubed roots, it's square, multiply square, like it's just a pattern that you memorize. And then when you solve them, the same thing happens. A pattern emerges. And it's because of the nature of the numbers that this pattern always happens. So let's look at the next one, and hopefully it'll answer whatever question you have. Okay? No, you can wait. All right. So let's look at 18. It's already set equal to 0. Is there a GCF? No. All right. Oh, you can recognize that's my cubes, right? 2 terms. I have a cubed on there. So it's my cube pattern. 2 sets of parentheses. Use your SOAP. So same, opposite, always positive. Cubed root of 8x cubed. Just 2. 2x. Cubed root of 1. Square, multiply, square. 2x squared. Multiply 2x times 1. 1 squared. Is there a question to this point on how I'm factoring? I hope we're doing okay to there. Just got to memorize the pattern. Now, for me to solve these, I like these because you recognize the pattern. They're fast to solve. What's this one? We know this. Negative 1 over 2. Right? We've been solving stuff like that for a long time in here. Now here, will it factor further? No. It will not factor, so you should use quadratic formula, but because of the nature of these problems, they have a pattern that emerges. Now, does that mean every quadratic formula I always use, no matter on what problem, I can use this pattern? No, it's only on the cubes. That's where a lot of students get themselves in trouble. They're like, oh, for always and ever, it's going to be this pattern. No. Yeah, some people seriously, like any random problem, they try to use this pattern. It's only on the cubes. It's because of how the nature of the numbers work together. So it's going to be x equals, start your quadratic formula. It's negative b, which would be 2, plus or minus, it's the same number you just wrote, with an I, and a radical 3, over 2a. 2 times a is 8. 2 times 4, you knew what I meant. I followed the pattern. So Tegan's one that should just use the quadratic formula and continue and do it old school. The pattern for these, you're going to have to solve this one, set equal to 0 and solve like normal. But then it's x equals negative b plus or minus bi radical 3 over 2a. These are always when you're doing only on the cubes. Only on the cubes. Not every quadratic formula from here until the end of the earth, just the cubed ones. Yeah, it always falls that way. But then I have to simplify this, right? Yeah, all 3 numbers can be divided by 2. Do I need the first one? Yes. Adding 1 makes a difference. I don't need the 1 here. All over 4. Got it? That first one you need because that's being added. Yep, that's your pattern. That just, it's the way it falls. It's the nature of just the numbers that are being used. You got to factor it. You got to factor it. And then when you're plugging it in to solve, instead of doing the full quadratic formula, it'll simplify to this. Yeah, so you can just do that. Yeah, I love it. Because I need you to know, if you forget the pattern, what do you use? The quadratic formula. It always works. It just, because of the nature of the numbers, it works like that. Nature of the numbers. 19 on your own. All right, guys, let's take a look at 19. Some of you, when I asked earlier, was there anyone struggling with factoring? And you're all like, no, we're good, we're good. I saw a couple people not even factor this. And let's hope because you're just lazy or something that it's not because you don't know how, because it makes me nervous. If you don't know how, you need to ask me, okay? First thing, set it equal to 0. First rule of factoring is what? GCF. I don't think anybody took it out at first. Yeah, there's a GCF here. Take out a 2. So 27x cubed minus 8. Because some of you went to factor it and you're like, cubed root of 54, typed it in your calculator, and you're like, that didn't work. Okay, so that's a red flag for you guys. At the point of the game that we are at, everything should factor. you know, 2. It's a huge one. 2. All right, so now we can factor. Little parenthesis, big parenthesis. We use our SOAP. Same, opposite, always positive. Cubed root of 27x cubed. 3x. If you don't know your cubes at this point, that's fine. Grab your calculator. If you don't know how to use your calculator, ask me. All right, cubed root of 8. I don't care anymore. Square, multiply, square. 3x squared. Multiply. And square. There it is factored. Baby brother, give me an answer. When would he give me an answer? If he has an x. Good. So right now, baby brother, don't care. Solving. This one gives me what? 2/3. This one, factor further? No. Quadratic formula. Or if you're smart, and listen to me, you can use it. You can infer what you want from that. I didn't say it. Yes. Yes. All 3 of these can be divided by 6. No, I don't want the negative on the bottom. So -1 plus or minus I radical 3 over 3. How many answers is this one? If the I is on the bottom, I will never be on the bottom.
No.
Nothing.
Negative.
Then move it to the top. Just divide by negative. It'll flip all your signs then. All right. How many answers should this problem have?
3.
How many did I get? I did get 3?
Yeah, 4.
She can count to 3. 1, 2, 3. No, you're right. This one's 2. A lot of people forget that, right? You have a positive, -1 plus I radical 3 over 3, and -1 minus I radical 3 over 3. That's 2 answers. And then that's another. Shut up, Jonas. All right. Questions on solving. Looks like nap time outside.